Nvidia is working with Apollo, BlackRock, Blackstone, Brookfield, Goldman Sachs, and KKR on independent AI compute financing platforms, intended to mobilize more than $500 billion in third-party capital. That figure matters, but not because it proves a build-out is already happening at that scale. It matters because it shows how AI infrastructure is starting to be framed, not simply as a technology purchase on a company balance sheet, but as something that may be financed more like infrastructure. That distinction is important. A financing platform is not the same as deployed capital, and deployed capital is not the same as usable compute. GPU-heavy AI capacity has also not yet established itself as a mature infrastructure asset in the same way as roads, ports, or power plants. So the right reading here is not confirmation, but direction. If institutional capital increasingly moves into AI build-outs directly, then demand visibility changes across the hardware stack. For Asia, that reaches far beyond chip design. It touches memory, packaging, storage, power systems, and the industrial capacity needed to turn financial intent into actual computing output. The first constraint sits in packaging. TSMC has reported a 98% yield rate for certain CoWoS products tied to AI applications, specifically around a 5.5x reticle size. This is a narrow data point, but it points to a larger shift in how AI hardware should be understood. Leading AI chips are no longer defined only by wafer fabrication. They depend on advanced packaging that brings together compute dies, high-bandwidth memory, and interconnect structures into one functioning unit. That process has to work cleanly at scale. When it does not, defects are expensive and often difficult to recover later. The numbers should still be handled carefully. It applies to certain products, not to all CoWoS output. And it does not tell us about customer mix, volumes, or future capacity. But even with those limits, the signal is meaningful. In the AI stack, packaging execution is becoming a strategic control point in its own right. Taiwan's position is not just about making advanced chips. It is also about assembling them successfully into systems that can actually ship. If packaging yield cannot scale with demand, then capital and wafer supply alone will not determine how fast AI compute expands. That same bottleneck logic extends into national policy. South Korea has introduced a semiconductor ecosystem fund reported at roughly 5 trillion won, or about $3.3 billion, aimed at design, packaging, and materials companies. The stated strategic intent is to broaden Korea's semiconductor base beyond Samsung Electronics and SK Hynix. That matters because Korea's global strength has been concentrated in memory. In an AI cycle where packaging, materials, and design capabilities matter more, concentration can become a structural weakness. At the same time, this remains an early policy signal rather than a proven industrial result. The available information does not specify administration, timeline, recipient criteria, or which companies will benefit. So the significance is not that Korea has already solved an ecosystem gap. It is that policymakers appear to recognize the gap and are directing capital toward it. For investors, that is useful as a strategic marker, but not yet as evidence of outcome. The storage layer adds a different kind of exposure. SK Hynix is reportedly reviving a long-frozen expansion at its NAND flash facility in Dalian, China, targeting roughly a 50% increase in output, linked to rising global demand for AI-related enterprise storage. This is a reminder that AI infrastructure is not just about accelerators and high-bandwidth memory. Enterprise AI workloads also require large storage capacity, and that creates demand for another part of the memory market. What makes this development especially notable is where it sits. A South Korean memory producer expanding output in China, while US-China technology restrictions remain in the background, and domestic competition such as YMTC continues, underscores how commercially important and politically sensitive memory investment has become. It shows that the Asian AI supply chain is not organized only by efficiency. It is also shaped by jurisdiction, policy risk, and the possibility that strategic constraints can interrupt industrial logic. Beneath the hardware stack is the power layer, where another risk starts to appear. A warning from an ICIT panel argues that AI data center growth, together with related electrotech infrastructure such as batteries and virtual power plants, may strengthen grid resilience while also widening the cyber attack surface and deepening reliance on specialized components manufactured in China. The warning does not identify specific companies, incidents, or named component categories, so it should not be treated as evidence of a defined failure. But it does introduce a useful line of analysis. Much of the AI discussion stays focused on chips, servers, and capital budgets. This warning shifts attention to the systems underneath them. If AI infrastructure pushes more investment into power management, storage, and grid-linked equipment, then resilience and cybersecurity become part of the compute story rather than separate issues. That is especially relevant when key components may be concentrated in a politically sensitive manufacturing base. The battery story sits next to that, not directly inside the AI data center market, but close enough to matter for supply chain optionality. U.S. battery manufacturers are reportedly accelerating sodium-ion plans by using production lines that can also support lithium-ion manufacturing. The potential significance is straightforward. Shared line manufacturing may reduce upfront capital intensity and may lower exposure to geographically concentrated lithium supply chains. But the information is limited. There are no company names, volumes, sites, or timelines. So this should be read as a hedge and a flexibility play, not as proof of a major battery transition. Taken together, these signals form a more realistic map of the AI build-out. The story begins with finance, but it does not end there. Capital has to move through advanced packaging, through ecosystem depth, through storage capacity, through power systems, and through supply chain choices that reduce concentration risk. At nearly every layer, Asia remains central. Taiwan in packaging, South Korea in memory and industrial policy, and China in manufacturing exposure across storage and infrastructure components. For investors, the discipline is to stop treating AI infrastructure as a single GPU demand story. The more important questions are whether financing platforms convert into funded projects, whether packaging yield holds as volumes rise, whether Korea's fund reaches firms that genuinely broaden the ecosystem, whether SK Hynix's Dalian expansion can progress within policy limits, whether power operators define China-linked component risk more clearly, and whether sodium-ion manufacturing attracts real capital and customer qualification. The next phase of AI infrastructure will depend less on headline chip demand than on whether these quieter bottlenecks actually clear.